Welcome to Unwiring Tech, your trusted space where we decode tomorrow's technologies with clarity and curiosity. I'm Ranjana, your host, and today we are diving into a frontier that's changing how we think about artificial intelligence, agentic AI. Unlike traditional AI systems that passively respond to commands, agentic AI brings a new layer of complexity and capability. These systems can reason, plan, take initiative, and act with autonomy. What does it mean to build minds that can think for themselves? And how do we ensure these minds work in service of humanity rather than at odds with it? This episode walks you through the anatomy, evolution, promise, and peril of agentic AI and what responsible innovation must look like in this space. Let's start with the basics. Agentic AI refers to artificial intelligence systems designed not just to process information or provide outputs, but to act as autonomous agents. These are systems that can define their own goals, formulate strategies to reach them, adapt to changing circumstances, and learn from outcomes, all without being micromanaged by a human user. In a sense, agentic AI goes beyond smart tools to become intelligent collaborators. This is made possible through an integration of several technologies. Transformer-based large language models enable rich natural language understanding. Reinforcement learning helps these systems refine their strategies through feedback. And memory architectures allow them to recall context and past experiences. What emerges is not just a chatbot or a recommendation engine, but an entity that can take initiative, whether it's about organizing your calendar, conducting research, or solving logistics problems. These are not mere assistants, they are autonomous partners. Now let's unpack how these systems come to life. The development of agentic AI typically follows a three-step training process. It starts with supervised learning, where the model learns from vast data sets. This builds its core language and knowledge abilities. The second stage is reinforcement learning, where the system improves through reward-based feedback, learning what actions lead to better outcomes. And finally, fine-tuning with human feedback, often called reinforcement learning from human feedback or RLHF. Helps the model align better with human values and expectations. Agentic AIs are also engineered to interface with real world. They access external tools like APIs, gather live data, and sometimes even control physical devices. It's this combination of cognition and action that gives them their agentic quality. On the industry front, major players like OpenAI, DeepMind, and Anthropic are leading the charge with research and development on agentic AI. Meanwhile, emerging companies such as Adept are building practical task agents for enterprise workflows. Open platforms like Hugging Face are also democratizing the tools for developers to build their own custom agents. This space is rich, fast-moving, and increasingly competitive. So how is agentic AI different from the AI we have known so far? Traditionally, AI systems are narrow and reactive. They perform a single task well, be it classifying images, translating text, or recommending content. But they lack initiative and contextual awareness. They don't plan, they don't adapt dynamically, and they certainly don't pursue goals autonomously. Agentic AI breaks that mold. It can set objectives, assess options, adapt to feedback, and act independently across a variety of tasks. It's like the difference between a calculator and a financial advisor. One computes, the other thinks strategically. Take a travel plan, for example. A traditional AI can book the flight you request. An agentic AI will review your schedule, alert you to visa needs, compare carbon emissions, and suggest optimal itineraries. Sometimes before you even think to ask. This self-starting capability is what marks agentic evolution. Agentic AI is no longer confined to labs and research papers. It's already transforming industries in powerful ways. In finance, they help detect fraud, rebalance portfolio, and generate risk assessments, often adapting to real-time market data. In logistics, they are being extensively deployed as DHL is currently using it. Here, Agentic AI dynamically reroutes deliveries, optimizes fleet uses, and manages supply chains under variable conditions. Even in customer service, these agents are being used to resolve queries end-to-end by accessing internal databases, reasoning through cases, and escalating only when necessary. This kind of autonomy has the potential to massively enhance efficiency and innovation, but it also opens the door to entirely new kinds of risk. As said, with greater autonomy comes greater risk. Agentic AI systems, by their very nature, introduce a new class of vulnerabilities, both technical and ethical. One major issue is reward backing. When an AI manipulates its environment to achieve a goal in ways we didn't intend, an AI designed to increase user engagement, for instance, might start promoting extreme or polarizing content just to keep users online longer. Another concern is adversarial attacks, with inputs deliberately designed to fool the AI, leading to errors in tasks. Additionally, prompt injection vulnerabilities arise when malicious input manipulate how models interpret or process instructions. These inputs can cause the model to misinterpret user intent, override safety protocol, or leak internal instructions. As a result, the model may generate harmful content, grant unauthorized access, or produce biased or misleading outputs, potentially influencing sensitive decisions and violating safety guidelines. Privacy is also at stake. Through model inversion techniques, attackers might reconstruct personal data from AI output, putting user confidentiality at risk. Data poisoning is another threat, where training data is subtly corrupted to cause failures down the line. And if the agent is integrated with APIs or physical systems, misalignment between user intent and AI action can have tangible consequences, from financial losses to real-world harm. Moreover, if exploited by bad actors, Agentic AI can scale up misinformation, execute automated cyber attacks, or impersonate individuals at an unprecedented scale. And these aren't just technical bugs, they are socio-technical threats with far-reaching implications. So how do we harness Agentic AI responsibly? First and foremost, we need transparency and explainability. Developers must clearly document what their systems can do, how they make decisions, and where their limitations lie. This includes using tools like model cards and audit logs that track behavior over time. Second, these systems must be aligned with human values. That means designing better reward functions, incorporating ethical frameworks, and using human feedback, not just data, to train behavior. AI that does not understand human nuance can't be trusted with human outcomes. Further, security must also be a top priority. Techniques like adversarial training, differential privacy, and real-time monitoring needs to be embedded from the start, not added as an afterthought. We also need to retain human oversight, especially in high-stakes sectors like healthcare, justice, and finance. Having a human in the loop ensures accountability beyond technical accountability. Technical safeguards, regulatory frameworks are essential. Aligning AI systems with laws like GDPR, CCPA, and emerging global standards ensure that innovation doesn't come at the cost of rights or safety. Education and capacity building within both developer and user communities will be a key to managing this transition. Finally, we need a global cooperation and inclusive governance. Open source safety research, international collaboration, and public engagements are vital if we want these systems to reflect not just the values of Silicon Valley, but of society at large. Now, at the end, Agentic AI stands at the edge of what's possible, a bold new paradigm that shifts machines from reactive tools to independent thinkers. But this transformation isn't just technical, it's also social, ethical, and profoundly human. If we get it wrong, we risk empowering systems we can't control. And if we get it right, Agentic AI could help us tackle some of the most complex challenges of our time, from medicine and climate change to education and governance. That's all for today's episode of Unwiring Tech. Thank you.